All right. So thank you very much, everyone, for tuning in today. And in today's episode, we have Raul Junco. He's going to introduce himself. But he's a software engineer with over 15 years of experience. And today, he's going to be talking to us about databases in backend engineering. All right. We understand that database is a very important concept, and it's one of the core concepts of backend engineering. And for those thinking that backend engineering is just about writing APIs and making API faster, it is not. There's a lot of component that comes together to make that API to work, and database is one of them. So today we are going to deep dive into databases with Raw. Let's welcome him. So Raw, introduce yourself.
Hey, thank you so much. Thank you for having me on this podcast. I think it's going to be an incredible adventure for you. So, my name is Raul. I have been in backend development for 16, 20 years right now. I'm an engineering manager by day. I used to call me a writer by night. So, you can find me simplifying system design concepts and engineering concepts on LinkedIn or Twitter or my newsletter. And yeah, totally agree with you. Like, if you think about database, right? Database, they create the memory for our software, right? So they can track interactions, they can track inputs to our software and outputs. They are the backbone of the application. There are in 90% of the applications we build right now, they require some kind of storage. And database is probably the storage for using.
All right, nice. So just a heads up. So Roll has been my friend on Twitter for a long time, and this is the first time we are meeting. It's really a blessing to have him on the podcast today. Anyway, so we'll go over some questions, and he's going to throw insight into this question and help us understand how important databases are in backend engineering. All right, so can you tell us about your journey? First, let's start with that one. Can you tell us about your journey into backend engineering and what led you to focus on understanding databases very well?
Right, right. So this is an interesting discussion. So I went to college, right? So I come from traditional path, right? So I went to college, but believe it or not, during college I have the opportunity, right, to build real software, right, to belong to a group of people that can actually work together and deliver real software for the university we were studying by. So some clients come to the university, some sponsors come to the university, they ask the university to build something for them,
Hmm.
and we help them to deliver that software. So what that means is that I have the ability to skip some of the classes, right? From my schedule to
Uh,
to make this presentation about that software. And one of the classes that I actually skipped was some of the SQL classes, some of the database design classes,
wow.
and I learned probably the most important lesson of my life skipping those classes, which is you shouldn't, right?
Yeah, yeah.
So so I can skip the class, but I cannot skip the test, right? So what happened is, when the time the first test hit, hit me, it hit me really hard. Right?
Definitely.
So I understand the message. I understand the message, right? And I went back and recovered the time basically that I didn't spend in the classroom,
Hmm.
studying myself, learning about database design. I went to but that time there wasn't a lot of online material, so I had to go back to the books. I had to read. I had to go back to books. I had to learn old school design. So, like I say, it was a home like those kind of moments that teach
Hmm.
you a lesson and put you in the right path again, right?
Exactly.
So again, I graduated. I stopped working for the university. I graduated and started working for the company, the great company, building real software. I blessed with that opportunity, um, and I start like every single probably software engineer. I start like a full stack. I do whatever we have to do, right? And I feel like it's a good thing, right? Because you have the opportunity to try like different things, right? So you do a little bit of UI, you do a little bit of backend, you do a little bit of database design. At that time, remember the things, the trending was created things around different specializations, right? So you have a
Yes.
database team, you have a backend team, kind of backend team, and then a front end team, right?
Mm.
That changed during the year. I feel like it's a good change, right? So um, so I have the opportunity to try those three main areas, right? I discovered myself liking a lot of backend side. Right? So I'd say, yeah, I like UI. I can build whatever. I understand CSS. I like CSS. I understand how powerful it is. But what I really like, what I really enjoy,
Mm.
is building the backend, building the infrastructure, understand the business logic behind that, and building the persistent data, right? And that is how I get into like more into system design and database design together, right? But yeah, that's my story. It's kind of it's kind of interesting, right? So I learned that lesson the hard way, basically.
Yeah, it's very very interesting. Honestly, I think I have similar experience, but my one wasn't database because I never skipped database classes. I actually like database, so I was thinking I was going to be like a database manager or those kind of guys, right? But one class that I do skip was system design and analysis. So that's what the course was. I skipped that. Honestly, I regretted it because I've actually failed two system design interviews because of that. And I started picking it up. That was like last year. I started picking it up a little, and then I started writing about it. And that's how I got familiarized with system design. Right? Another important thing that you mentioned that I really love was the aspect of trying out different things. So you have that privilege to go into to check out UI, check out CSS, check out front end, and check out back end and databases. So that kind of gives you a lot of perspective around software engineering, and then you have to now pick one. So I did similar thing, but it wasn't for a company. So when I started development, right, I started with front end. So I usually do HTML, CSS, and I didn't know JavaScript then. So I'll basically just code out the HTML and then look for someone that will do the functionalities. Okay, so that's how I started. And when I started JavaScript, it wasn't like Node.js. So Node.js didn't come out by that time.
Yeah.
Or maybe I didn't know about Node.js because I think it came out by 2009 and I started 2011. So I didn't know anything about Node.js. Right? I think I got to know about Node.js in 2017. Right? So I only did JavaScript for the front end, adding functionalities and stuff. But what I did was PHP. Right? So I did a lot of PHP, and I discovered that I am more inclined into the logical part of the business, like building out the logic and every of that. But for PHP, the PHP of then, you were not able to separate it. You were not able to separate
Yeah.
PHP, like your server side and your client side. You do everything together. All
Right,
right?
right. No, I remember that. I remember that. I did, believe it or not, I did a lot of freelance. I have been doing a lot of freelance in my life. And
Mm,
PHP, it's a good money. It's there money there. So I in
of
some
course.
point I did PHP, and I remember using tools like a CMS, content
Exactly.
I, I remember Joomla.
Joomla,
Um,
that was very
yeah, yeah, it was
nice.
very good. Yeah, it was very good. I remember creating plugins for that, and
Yeah.
render backend, render front end from backend. It's
So
interesting.
I used to do WordPress. I used to do Joomla, and I used to do this forum CMS, body press, body press, something like that. So I used to do those back in the day. And in my country, right, if you know how to customize WordPress themes, like kind of write the code, you
Yeah,
will be a big boy. right?
Yeah, yeah, yeah.
So I used to do all that, and as time progressed, we started noticing that there's a way that we can separate backend and front end, through APIs. And I got to know about this using Node.js. So that was 2017. I got to know about how to do that, and it was great. And then Laravel came up and kind of give everybody a sweet way of doing PHP. So I enjoy the aspect that you are able to test out different things and then pick one that really interests you. Some people don't want to go through that route. Maybe they have the ability to just know that okay, they are going to focus on back end or they are going to focus on front end and they just go like that. But I feel like software engineering is software engineering, right? They should have broad knowledge around software engineering and then choose a specific area that they want to focus on. Maybe back end, maybe front
Yeah.
end. Okay, so I feel like
And
that's what
and and this is what is great about doing freelance, right? Doing freelance teach you a lot of lessons, right? That if in a regular job you don't have. You have to negotiate your contract. You have to talk about, with your clients, what are your requirements. You have to
Mm,
gather your requirements. You are responsible for doing that, right? You are responsible for deliver a product, right? For deliver a functionality, an entire functionality versus, oh, my scope of work is building this endpoint right here on this API, right? It's a different world and teach you a lot of lessons that you can actually apply later. And even
yeah.
if you want to create your own company, now you have those tools, right, that you can use.
Yeah. So I think that it's actually nice. I don't have a lot of experience freelancing. I actually tried, but I couldn't get jobs. So I had to go look for a company to work for. But one thing I know I'm sure of is even in the company where I worked, I was doing everything, right? So I was kind of the person doing
Yeah.
everything. And that gives me that same knowledge of a freelancer, right? So it is now, like recently, around 2 years ago, that I started doing freelancing, and it's been really great because I already have that kind of experience of doing everything, both front end and back end. It's really a nice experience. So freelancing route is great for someone that is kind of starting out that had experience and want to build up on that, right? So you go into that, build lots of software and own the entire process from negotiating to delivering a product. And that gives you a wide experience around how to one, build a system and two, even start a business of your own. Right. So
Yeah.
it's great. All right, so we have the next question actually, and it's in your experience, right? What are the most common mistakes that backend engineers makes with databases? Okay, so regarding to databases, and how they can avoid them.
Yeah. So okay, I think the most common mistake is not paying attention to your design, right? Your modeling the database is not a science, it's an art. And if you don't pay attention to your design, you don't if you don't understand the nature of the data, right? It's when you make these mistakes about normalization, right? So I think poor normalization is the first mistake, right? If you don't understand the context, the third form, the third form or three forms of normalization, you are in trouble, right? So that's the first thing. That's the first concept that you need to master, right?
Mm,
Because those are giving you the foundation to a good model design, right? Second thing is over normalization, right? So if you go too deep into the normalization process, in some
mhm.
point you will hit that over normalization, right? Especially if you are talking about systems that require like a quick read, right? Or a high throughput information, normalization is going to be your enemy. And you have to learn how to denormalize your system, right? And
Yeah,
going back to focus on performance. So that's another mistake, trying to fix your mind into normalization. That I feel like that is a kind of mistake too. So you have to be able to adapt, right? The other common mistake ignoring indexing, right? Indexing is powerful. Indexing is the way you optimize your outputs. You get a good performance on your query. They are not free, right? So they are coming with a price, and the price is every time you write data in a table. If you have 20 indexes, those indexes need to be updated, and in some point it can cause performance issues. So you have to be aware of this because the amount of data on the table combine it with the amount of indexes, it can lead into performance issues. So you have to pay attention to those. They are powerful. They should be your first resource for optimization. But please pay attention. They are not free. Third thing, we can think about lack of constraints, right? So the problem with the lack of constraints is that if you don't constrain the quality of the data that you put inside your database, in some point that that data is going to come back to you and you have to fix it, right? And fixing data is not easy, and it's expensive in terms of time. You can fix it at the time of the of your output that data, so you can like, okay, this is if this is a null value, please use this default value, right? That's when we hear about when the time you output that data. But the problem is that that's knowledge, that's not writing in any place, right? So in some point, new developers join to the company, they don't know that knowledge, and that null value get out all the way to the UI, and you don't know what's going on in your system, right? So it's better to fix that problem at the source, right? At the database. So avoid people to write null value in that column, right, from the beginning. And that's when the constraints get into place, right? And you can use a default constraint for that, or simple business rules like, oh, I know the temperature will never reach more than, I don't know, 120 degrees, right? So I will put that constraint in so nobody can write down 300 degrees in the database, you know.
Yeah.
So it's more about preventing your data to get bad. And trust me, it's way cheaper to invest time getting these rules in place than fixing later down the road. It's way more cheaper. The second thing, there are another couple of mistakes like poor naming conventions, right? And it's when you see those schemas, those database schemas, some people use underscore or separate the name. Some people use camel case, and you can see that mix, and you don't even know how to store procedure on the table. You can think about. So that's another thing. Easy to fix, right? It's just create a documentation, create a guideline, simple guideline, say tables naming in this convention. Store procedures we name in this way. This is the way we name functions. This is the way we name constraints. Most of the time, those conventions are out there. Some like Microsoft SQL Server have their own conventions. Postgres or they have MySQL have the underscore. So if you follow those conventions, it's going to be way more easy for the team to interact with the database and with the schema, right? And design it. And yeah, I think those are common mistakes. Another common mistake that you have to pay really attention is security. It's underrated. Like people don't pay attention about okay, which roles should be reading or writing into the database. That could be problematic, right? Because if the write access role, some people get access to the right access call, it's gonna be
Yeah.
can damage your data. So I think those are common mistakes. There are way more, like I don't know, not planning for scalability of your database, not planning for backup and recovery, right? And that can hit you. Right? If you lose your data, I mean, think about it. If you have an error in your API, right?
Yeah.
And you get down for 10 minutes, right? An hour, a day. That's recoverable, right? You have to make your excuse, right? You have to basically say sorry for that, but you can fix the problem. Imagine if you lose your database.
I can't imagine
There is
that.
Yeah, there is no go back from that. There's this
Is
so plan for your backup. Make sure you have a plan in place to restore, and they are viable.
yeah. So you've actually mentioned a lot. Like let me start from the last one, right? The point of having backup system properly set up for your databases is
Mhm.
like it should be the number one thing that you think of when you start setting up databases, right? Because if you lose, like you said, I can't even imagine losing my database because it's even expensive to start imagining it. All right. Imagine you have like 1 million users in your database or wherever, and then you lost it, right? It's going to be so
Yep.
expensive that you cannot ever get it back, right? So backups and recovery process has to be put in place to make sure that it is it is there. And another important thing is security. You mentioned that it's very important. So why I said it's important is this: you need to define roles and permissions in your database level. Understand that we have application level. Some persons do roles and permissions at application level, which is great. But that same thing should also be applied to database level because if someone bypasses your application level, it goes straight to the database level and has access to everything, right? And that's not good. Okay, so you should
Yep.
also make sure that you have security embedded in your database level, which is very, very awesome. And
Yep.
then you talk about schema naming. Okay, I'm at fault in this one. I don't really
Yeah. Yeah.
consider schema naming or anything. I think I just follow. I follow like if I'm using Prisma, I follow Prisma's pattern. If I'm using any ORM that has a specific pattern, I just follow that directly. So I don't really give a thought about schema naming and then writing out guidelines. I don't do that. I think I will start doing that. It's actually best practice to do that. And then the next thing is indexing. Indexes are so important because when you start having lots of data in your databases, right? You want them to be fast, especially if you start doing searches. You want them to be very fast in terms of response. And indexes are database level of optimizing your databases. Aside from when you do caching for application level, indexes are the next database level caching. I like to use the word caching because it makes it fast. All right.
Yep.
So
Yep.
indexes are so important that you need to always define it before your database, start getting bigger. All right. And then another thing is normalization, which is also great, right? Some people don't consider these things. For example, you notice that someone is going to type in just name, first name, last name, and then you're making that colon voucher maybe like 255 or the highest length. Why are you doing that? Okay. Why is the person going to type? Is the person's name
I
so
think.
long?
Yeah. Yeah. I think it's an interesting case, right? Because here's the thing: as the tools get easy to use, right?
Yeah.
So you start like getting a little bit lazy. So at the beginning, right, we have to set up our database server bare metal, right? So we have to buy hardware for it. We need to understand what's the memory we need to consume, what's the size of the hard disk, everything, right? Right.
Yeah, yeah.
So you go and design your database, optimizing all those things, right? So you go and optimize your field, you go and optimize the size and the type that you are going to be using and everything, right? Because you understand what's the trade-off, right?
Mhm.
So we have to create the cloud, right? We create the cloud. Now it's free for use, right? So you can scale, doesn't matter. And it's kind of okay, I don't care that a lot anymore, right? and you start neglecting the process to think about, let me optimize my database for this, right? Oh,
Yes.
my server is slow, my queries are slow, right?
Mm.
Before the cloud, you go and say, okay, let me try to optimize this as much as I can, right? After the cloud, maybe it's okay, let's buy 2 more gigs, right, for this server, and that
Mm.
will make it fun. You know what I mean? So I feel like the cloud was an incredible advantage, right? But also come with a price, right? You can get lazy, and you can actually neglect some of the tasks that you had to do to build a better database.
Exactly. So at that point where everything is now so easy, makes us, the engineers very lazy to actually fix these little minor things, and that comes under normalization in databases. You have to take it very, very important. According to what Roller has actually said, you have to take it very important. Know the length of fields that should go into each rows, and then specify it accordingly.
Yep.
Okay, so the next thing you mentioned was
Yep.
constraints. So constraints is actually great, all right? And I think you need to also know where to assign secondary keys to different things, right? Because it's important. If you assign a secondary key to a particular table in your row, what is going to be the action if someone tries to delete? Is it going to cascade? Is it going to, kind of update? Is it going to delete? You need to also put all these constraints in place and know how to properly assign secondary and primary keys. So these are interesting points. Thank you very much for listing them out. And yeah, so the next question is, could you share like a specific project? This is talking about your personal experience, right? A specific project where your expertise in databases significantly contributes to its success. All right. Now, what are some of the challenges you faced and how did you overcome them?
Right. I think one of the more complex projects that I have been working is the current project. So, if you read books about database, they are always talking about distributed database, right, and distributed data, right,
Yes.
as a complex topics. But you don't really understand the complexity of that until you start implementing it, right? So the main problem is that once you are in your database, right, your single database, you can have rules in place. You use your foreign keys, your constraints. So you have the you have the ability to control the data in. The problem is that once you distribute your databases, right, and there are multiple systems writing into those databases, those rules doesn't exist anymore, right?
Mm.
So what happens is that different systems, different inputs, different rules, and they can potentially write different data. Right?
Mm-hmm.
So that's one of the problems. That's one of the things. You have no those safe rules anymore. So you have to create that kind of safe rules at the time you aggregate that information because that's another problem. The data is distributed. So you
Mm-hmm.
have to find a way to aggregate the data if you need that data together. And that's when you get into data warehousing and and analytics, right? And the books are great. They teach you the fundamentals of that, but the real life is different. In the real life, there are missing data, there are back data that you can join together. There are
Mm-hmm.
different IDs, different systems generate different IDs. And now you have to find a way to correlate those IDs and say, this representation right here for this data, it correlate with this representation IDs for this data. And those complexities, those are incredible, right? So yeah, so a lot of the skills, right, fixing that data, right, is
Mm.
making sure that data get aggregated together in a good way, right, in a good performance output, right. It's incredible hard. It's once you get into it's incredible hard. So yeah, I'm learning a couple of lessons with this project, um, especially in terms of denormalization. query optimization. I used to call it defensive programming, right? Which is basically think about everything that can go wrong, it will run, right? And you plan for trying to fix it, right? And in
Exactly.
terms of data, it's the same thing. You have to think about that. You have to, oh, this value right here, maybe it's gonna be a null value, or it's gonna be a different ID that I don't have within this side of the application. So I have to handle that case. Another big thing is eventual consistency. So
Yeah.
once your data stores are separated, now you will suffer from that. You will have data right here that is still in the process to travel to this side of the application or to this storage. And you
Mm-hmm.
have to think about that because it could be as simple as replication, which is really quick, right? You have a master and replicas, and that, yeah, in theory, it's really quick, and you never suffer for those, or almost never suffer for those problems. But it could be a different process. It could be a event driven design, an event driven architecture, moving data from this database to this data source right here. That communication establishes a latency, and you have to deal with that. And it's going to be eventual consistency while that information is traveling from data source A to data source B. So you have to live with that. You have to plan with that. And most important, you have to understand that that's the trade-off to distribute your data, right?
Yeah.
The
Yeah.
latency, the eventual consistency, and how your system are prepared. So
Mm-hmm.
yeah, that's really. I think this is probably gonna create. We can speaking on different podcasts, totally different podcasts about these issues. But X is a really interesting process. I mean project, and I'm learning a lot. So I like it.
Yeah. So distributed data is complex. Like that's the truth, right? It's complex. In terms of scaling databases, I feel like vertical scaling can work. Like I think adding more resources instead of kind of trying to distribute it can actually work for databases. But some companies prefer different databases in different locations and stuff. And again, right, one thing I like is instead of I use distributed database when there is no other option, honestly.
Right,
So
right.
I do particle scaling, add lots of resources to my database server and make it work. And the highest thing I know I do is to do database replication. Create different copies of that database and then assign master
Right.
slave and stuff. And if my database needs more server, I give it to it. Now, there are times that you have to do distributed, which is very difficult because you have to learn how to normalize all this data and which data, how do you access this data, how do you send the request to this data. So it's actually a complex thing to actually talk about. And I believe we will have another kind of interview where we talk about distributed data. But for now, I feel like personally, if I'm to choose between distributed databases and you know adding more resources to my database server, I feel like I'm going to choose
Yeah.
adding more resources and then
Yeah.
doing database replication than distributing my database.
No, definitely. That's a good advice. So first rule first, right? If you
Yeah,
don't need distribution, don't do it. Don't do it. If you can grow your server, like especially on your because scaling at the level of the API is different, right? So you can put a load balancer right there, and you can really quick scale multiple instances, right?
yeah,
If you are a stateless, that's not a big deal, right? At the level of the database is totally different. So I will say put your money on that big server, right? Maybe backups and everything, but put your money on that because it's way more easy than distributed that database or distributed data, right? So second level of that is okay, I reached the point where I can put more money, right? Or I'm taking too much risk. So let's replicate data and let's separate writing from reading, right? So I can now think about pointing all my source of reading uh, to the replicas databases, right? And I keep the writing. So I give him more freedom to that database and more
Mhm.
performance to that writing database, right? That will be the next level.
Yeah.
If you cannot get away from that, then it's when you have to think about sharding and everything. X when X when the things get complicated. Right?
Yeah. So
So yeah, definitely, definitely try to don't do that. I mean, and to be honest, let's be honest, like probably 80% of the companies doesn't need it. It's just when you reach those numbers. And there are another solutions for this. Like one of the solutions that I did for one company was specifically we having a bottleneck reading or searching for information, right?
mhm.
And it's very specific to the core of the business, right? There's a couple of entities, right? On
Yeah.
like if you think about products and orders, right? This is a classic example. If you have an e-commerce application, you want that search, right? Be optimal for finding your products, right? But if placing an order doesn't require the same level of availability and the same level of latency that searching for a product, it's different, right?
Yes. Yes.
Sending an email, it's a different level, right? So you can isolate levels of your application. So one solution for this is, okay, let's take the search information and put it in a different specialized mechanism. Right? Like you can think about search indexes like Elasticsearch or Azure Cognitive Search. I think it's now Azure AI. They renamed it to Azure AI. So but actually you can take that information from the database, putting in those specialized indices, and then point your application to those indices, right? And now your database doesn't need to deal with the search, you don't need to create like 20,000 indexes
Mhm.
for your database, because this specialized service right now is going to take, it's kind of separating reading from writing, but
Mhm.
don't not using database technology, but another technology that worked really good. And my database right now is free for just writing, right? And management. The searching that is optimized for search. So that's another technique that you can use. And probably you can get away 90%, 95% of the companies can get away from that.
Yeah.
And
So
it doesn't need to get into replication and anything.
definitely. So recently I was writing about database sharding in my newsletter. I said at the end, I said, please don't go straight to database sharding. So these are like four alternatives that you could try to do first. And if none of them solves your problem, then you can go through database sharding. So I said, number one, setting up a remote database and then implementing caching. Okay, so it could actually be that your application is slower because there is no caching. So try to implement caching first, and then next try to do database replication, right? And then lastly, try to
Yep.
do vertical scaling before you even think about what database sharding, because it's more expensive and it takes a lot of time for the developer to get it right.
Right.
Yeah.
And here's the thing. This is another topic that we don't talk a lot, but knowing your database strength is actually a good skill, right? Because I have one of the common mistakes I have been seeing is, well, people using a
Mm.
NoSQL database to store information that is transactional, right?
Mm.
You should be using like SQL database for doing that. What happened is because of NoSQL is trending, oh, let me jump into use that type of storage. And then what happened is that when the first report hit you, like, oh, I need a report to see all the orders with this product for this customer with
Yeah.
X with the NoSQL, yeah, you get it. So
Definitely.
knowing the nature of your data, right? How do you want to store your data, and how do you want to retrieve that data back? It's
Mm.
important in the process to choose what kind of database you need.
Yeah. So I think generally having deep knowledge of the fundamental aspect of databases is important because it's going to help you
Yep,
choose the right database for the right application or the right project. All right. So that,
100%.
that brings us to actually the next topic that we want to talk about. Now we have experience. I think at least I was a developer when NoSQL came out. MongoDB, like, we use that. So when it came out, everybody was all around it. So the trends. I was a developer back then, right? So how do you see the role of databases evolving in the next 5 years? Do you think there will be another MongoDB that is coming out? Or like
Right.
what new
Well,
skills should a backend engineer focus on to actually stay ahead of the game?
yeah. Well, I think for a long time we have been seeing these two forces, right? Like SQL database, NoSQL database, and
Hmm.
then we have been seeing what we call right now new SQL database,
Oh,
and
new.
they try to merge, yeah, they try to merge together the the good things for both worlds, right? Do that can reach in a scale that we can say, okay, this is gonna be the way we are gonna be doing. I don't really know, right? I've seen some cool stuff from Proper RCB. I haven't seen, performance and everything looking good, right? But I never used it in production, so I can talk about it. But what I can talk about the future, right? Data store and databases, they are not gonna disappear because we need to we need to have the memory. Our software need that memory.
Hmm.
And the trending right now is the data itself is important, but more important than data is the information you can extract from them. Right?
Mhm.
If you have ordered data in your database, you can extract behavior, right? Customers' behavior. You can extract trending. You can predict inventory, right? When you're gonna need to restock or not a product, right? That kind of thing. There is no way to there is no way to don't use data to predict that kind of thing. So data and databases are gonna be there for a long time. It's SQL open doors. That's what I used to call. I used to say this a lot because it's a good skill to have in your profile, in your briefcase, and it's gonna allow you to jump between like backend, database design, data analytics, data science. So it's a skill that a lot of roles in the engineering world need, right? So it's a good skill to have. It's a good thing to invest on your database skill because you can jump into different fields, you can try different things, and the future is gonna be that. The future is gonna be on the data. So yeah,
So also, right, most importantly, right, I like to tell people that no matter what is trending in terms of databases, SQL is here and it's going to remain, right? Because you
yep,
cannot you cannot manage large scale data without SQL. Like I don't think it's that possible, you know, to do enterprise level application without using SQL enabled languages, right? You know, we have no SQL is there. I was studying about it because I wrote a newsletter around it. So I know that there is a lot around no SQL. Like many different products are actually coming out for no SQL. All right, so if I can reference this back, you notice we have document databases, we have key value databases, we have white column
right,
databases, graph databases. All these are under the umbrella of NoSQL database. Within these four major types, there are different companies or different types of databases that are coming up within them. It is difficult to keep up with the trend, right? It is really hard to keep up with the trend. But one good thing around all these things around databases is that SQL is going to be SQL. So if you know the SQL language itself, not the databases, if you know the language, that SQL language itself, then you can access every other SQL relationship, whatever, in the own databases, which is great, which is where every backend engineer should actually focus on, right? And maybe add
Great. Yeah.
NoSQL as an add-on to their skill, because the more different NoSQL languages are going to be coming out, the more it's going to be saturated, and people are going to be confused on which one to actually pick. So that's my thought around this stuff.
Yeah. Yeah. And think about it. SQL was, if my memory serves me well, was invented in the 70s by IBM. That was the
Hmm.
first introduction. I think was general availability by the end of the 70s. Um, if you think about it, right, how much SQL has been changed since you know SQL, since you start, learning SQL. It's so good, it's so well designed, and it solved the problem so well that it having minor updates like, okay, support JSON right now, it's optimize the queries, different ways to write, different ways to read, minor optimization that they are good, they are great, but there is no major fundamental change on the language, and it's
Hmm.
because the language is so good and solve the problem so well that they don't need it. So
Yeah.
yeah, I definitely. Yep.
So for those guys looking for the next evolving technology in database in the next 5 years, I'm going to say invest more in learning SQL language, right? Invest more in
Yep.
it. Expand your domain knowledge in SQL, right? And then with that knowledge, you can actually do any type of relational databases that is coming up in the future, right?
Yeah.
All right.
Yeah.
So nice. So the last question is for those just starting out in backend engineering. So this is more like you advising us, So for those just starting out in backend engineering, so what fundamental knowledge and practices would you recommend we focus on to be proficient?
Yeah. So I think the first one, the top of the list, is learn normalization. Right. So normalization, it give you the tools to database design, and you should learn, you should master to the third form, normal form normalization. That's what I used to go most of my designs. That's the first. Second rule is, of course, learn SQL, right? So you familiarize with the language, familiarize with the different clauses of the language, right? Where to use the where, order by, so by, whatever you need, right, on the system. How do you how do you join two tables, right? What's the difference between different joins and everything, right? So that's the flow. What are the commands that write to the database? What are the commands that read from the database? What's the
Mm-hmm.
difference in those? What are the Windows functions for using if you get into more advantage use of SQL. Second thing is how you get your indexing the right way. Right? How do you index your database the right? How to manage transactions, right? Transactions are important in transactions database, right? How do you design your system to support transactions, right? And how you implement those transactions, which operations should be done inside that transaction. Understand what are you locking, because every time you do a transaction you are locking your database, right? So, or some tables, right? So understand how to use it efficiently, right? What else? And if you get into like a more advanced topic, right? So that's when you think about, okay, how I design my database to be scalable, right? How, if I need to distribute my database, how I will doing, if I do charting, what will be the key to do those chart, right? But that's, again, that's a really, really, really high end topic. Um, but again, and the other important thing is like which type of database is the best for your application, right?
Exactly.
So when you use NoSQL database, when to use a column database, when to use a key value database, when to use relational database, why you should be using that instead of this is the trending thing. Understand why, right? Because the why is going to give you the ability to choose the right tool.
Exactly.
More than that, structuring tables, using the right type of data, indexing, normalization, security, right? How to set security, how to isolate different users to use the database. What else? Conventions for the names. Understand how backup and restore functions, right? And create a plan for that. Because when the bad things happen, right? You don't you don't rise to your expectation, you fall to your plan, right? So you have to have a plan in place. And again, enjoy the ride because SQL is incredible. It's gonna give you the skills to so many fields into the engineering, right? It's
Mm.
gonna be backend, system design, I don't know, data analytics, data science. It's incredible. So it's one of my go-to skills. And guess what? It's one of the first skills that I ask in any interview for a backend engineer. So how are you familiar with SQL? And I feel it should be a must, right? Yeah, that's those are my two cents on SQL. Learn SQL. SQL open doors. So database design is one.
Yeah, this is nice. This is really awesome. I know some of the newbies in backend engineering are going to say like, oh, well, there is ORMs for these things. Why do we have?
Right.
Why do we?
No, ORMs are great. I use ORMs are great, but you need to understand the fundamentals and the trade-off you are doing when you're using ORM, right? Most important, you need to understand how that ORM usage translate into database side,
Exactly.
right? So, what query are you running your database? What structure are you generating? You go with the code first approach, right?
Mm.
So you have to go and do your task. And like a lot of people say, no, ORMs are bad for developers because they are gonna forget SQL. I don't feel that's 100% true. But what happens is that just because the ORM is so easy to use, right? You forget about you have to add this sentence right here to add a foreign key. You have to add a constraint. This is the way you add a constraint to the table, right? People just okay, this is the structure of the table. Put it in the database. That's it, right. And then you forget about this indexing. You forget about your constraints. You forget about using the right type of data. You can specify most of the URM. For example, if you are defining string type, right?
Mm.
If you leave it by default, it's gonna use the default. I don't know, 2,000 characters, right? But you can actually say, for this field that is in string, go and use 50 characters because that's the size of the field that I need, right? Most people forget that. That's true when you use it's easy to forget when you use ORM. I don't think they are back. It's another tool you can use it.
Exactly. So one comment I like to make when I hear people talk about ORMs and having core database skills is this. ORMs gets the job done, no doubt. It's good, it makes it fast. But to get the job done very well, you need to combine your ORM knowledge and your core database knowledge. That's going to help you get the
Agree?
job done very well, right? Because
Yep.
you have to checkmate the ORM yourself and then put everything that you know as a core database engineer into place, even with the
Yep.
ORMs. Right?
Yep.
So that's my
Yep.
summary of
And
them.
pay attention. Like for example, one of the features that Entity Framework added, like I don't know if version 7 version, I don't remember, but one of the features is that you can actually, when you do a query on Entity Framework, you can actually add a tag to that query, right? And you can say quick tag, and you can actually write down a comment, right, on that tag, And what happened is that when the when the ORM execute the query on the database size, it's gonna add a comment in your query, and you can see, oh, I use this query to query the list of persons, whatever, right?
Mm.
So if you have a problem if you start noticing problems in your database, right? You can go see the query, check the comment, that comment right there, and
Mm.
identify what's the ORM sentence that is
Yeah.
producing that query. So you know you can go and fix it. I love that feature because before that, you don't have idea which statements on your code is
Mm.
generating that sequence. So you cannot correlate, and or you have to spend a lot of time trying to correlate which query is causing the problem, right?
Yeah.
This feature is something cool. Most of the people don't use it, right? But I it's right there. But you have to have, again, you have to have the SQL knowledge, right? The database knowledge, because once that query hit the database,
Mm.
now you have to think about a way to fix the problem. You have to understand what the problem is on the SQL query that the ORM is generating, right? And now you have to make decisions on the ORM side, saying, okay, instead of doing this way, let's do it this other way. Let's try to get a better performance, or let's split this query in two queries because it's more optimal to retrieve that information in two separate queries. Even if I hit the database twice, right?
Mm.
It's going to be easy to bring that information to separate queries and then merge it together on the backend, right? Aggregate it on the backend side. So
Nice.
again, it's a tool. You have to use it the right way.
So I will try that out. I will try that out and see how it goes. So great. This is the end of the podcast, and it was really nice. Actually. It was really awesome. So now it's time for promotionals. Like if you have anything you want to share it with us, backend engineers, you can just tell us. Maybe you want to tell us to join your newsletter. Actually, join your newsletter today.
Thanks, man. Yeah. So yeah, I'm trying to. I start like writing as a hobby. I think a few years ago. Seriously, like a year ago, something like that. A friend of mine just pulled me into. Now I thoroughly hooked it. Can't stop writing. I write daily. Twitter, you can find me Raul Junco B or linking. It's Raul dash Junco. Had to fix those handles to make it the same. Recently, I started my newsletter. It's still super early. The newsletter is I hosted on Substacks, and it's called System Design Classroom. The reason for that is because I feel like social media is really cool, right? It's really good for connecting people, right? Like you and me, we connected on Twitter, right? So we
Yeah.
meet on Twitter, we connect. It's great, but for the content, if you want to go deep, reading, I feel reading is a good way to grasp. So having that email in your inbox talking about a really cool topic, it's important. At least it's for me. So I feel that's the best way to communicate. So if you want to go deep in topic, if you want to get some kind of interaction, that's what I create the newsletter. So I can expand a little bit of content. I can explain more. I can put more details. So yeah, those are the projects that I have in my plate right now. I'm spending a lot of time doing that. Yeah, and connecting with great people. That's all you can find.
Nice. I'm going to add the links to where they can get to you on the description of this video, and people are going to start connecting with you. So nice to have you on the podcast. So yeah, so for me, we're currently starting advanced backend engineering bootcamp. It's going to start next month, and if you want to register for that, just I'm going to leave the link on the description also, and you can connect with me. Of course, you're already connected with me for those listening. So you can connect with
It's
me
nice.
more, share this video to other of your friends. So this is my new podcast, and it was nice that Raw turned up for me. I really appreciate that.
Thanks, man. Thanks for having me.